What if you could fine-tune an image generation model on your own photos and run it entirely on the cloud with auto-scaling GPUs and no infrastructure to manage? That too, all under 50 cents of computing costs. In this video, I'll show you how to train a Flux.1 LoRA model and generate custom images using AWS Deadline Cloud. For context, Flux.1 is a lightweight text-to-image model, and LoRA is a fine-tuning technique that teaches the model new concepts, like a specific person or object, using just a few images to train. With Deadline Cloud, everything runs on managed GPU fleets. You just submit the job and get results back. Let's get started. Here's the workflow. First, we'll train a LoRA adapter on a set of custom images. In my case, 20 photos of my team member's dog. Then, we'll use that trained adapter to generate brand new images from text prompts. Both steps run as jobs on Deadline Cloud. We submit from our laptop, the work runs on GPU instances in the cloud, and we download the results when it's done. Let's begin with the one-time setup. In the Deadline Cloud console, I've created a farm, which is the top-level container for our workloads. I'm also creating a GPU fleet, service managed, meaning Deadline Cloud spins up and spins down the services for me, so I don't spend more than I have to. I'm using an A10G GPU, and I'm picking a worker size that is big enough to handle a LoRA training job. I'm also choosing a minimum of 64 gigs of memory, so we have enough headroom for the model. Finally, I created a queue with an associated S3 bucket for job attachments. I also associated the queue with the GPU fleet we just created, so when we submit a job, Deadline Cloud automatically spins up a GPU worker to run it. On my local machine, I installed the Deadline Cloud CLI with pip, then configured the CLI with my farm and queue ID so it knows where to submit jobs. This can also be done within settings in the submitter GUI. I also cloned the needed job bundles from the samples repo in GitHub. For training data, I have my PNG images in a folder. No caption files needed. The job will auto-generate captions from the instance prompt we provide. Now that we've cloned the samples repo, navigate to the Flux.1 LoRA folder and launch the GUI submitter. If you didn't already configure your Deadline Cloud CLI with your farm and queue ID, go to Settings and select them from the dropdown, and select OK. Then I set the dataset path to my images folder and chose the instance prompt to be a photo of ohwx dog. That's the trigger word the model will learn. I'm choosing 1500 training steps at 512 resolution. I hit submit and Deadline Cloud takes over. It uploads my images to S3, spins up a GPU worker, and starts training. In the monitor, we can see the job running. Training takes about 20 minutes. Once it's done, I download the trained weights. This gives me the final saved tensors file plus checkpoints from training. Now the fun part, generating images with our trained model. I run the job bundle for image generation with the command here and point it at the LoRA weights we just downloaded from training. I then give it a creative prompt. For example, this dog wearing a cozy sweater jumping into a pile of autumn leaves. And generate 4 images at 1024 by 1024 with 50 inference steps. More steps equals more detail, but slower generation, so keep that in mind. Add in your desired output directory as well. Generation is much faster than training, at just a couple minutes per image. Download the output to your desired folder from the completed job. Here are our results. The model learned what my team member's dog looks like from our training images and can now generate new scenes we never photographed. And that's it. LoRA training and inference fully managed on AWS Deadline Cloud. You simply train and generate. The sample job bundles are open source and the link is in the description. You can swap in your own images, change the prompts, and experiment. If you found this useful, subscribe for more Deadline Cloud tutorials. Thanks for watching.